Welcome to the channel Next Gen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
An aerospace company uses a proprietary data format to store its flight data. You need to connect this new data source to BigQuery and stream the data into BigQuery. You want to efficiently import the data into BigQuery while consuming as few resources as possible. What should you do? The options are: Option A, write a shell script that triggers a cloud function that performs periodic ETL batch jobs on the new data source. Option B, use a standard Dataflow pipeline to store the raw data in BigQuery, and then transform the format later when the data is used. Option C, use Apache Hive to write a dataproc job that streams the data into BigQuery in CSV format. Option D, use an Apache Beam custom connector to write a Dataflow pipeline that streams the data into BigQuery in Avro format.
To arrive at the correct answer, we focus on the keywords: proprietary data format, stream the data into BigQuery, efficiently import the data, consuming as few resources as possible.
The correct answer is option D, use an Apache Beam custom connector to write a Dataflow pipeline that streams the data into BigQuery in Avro format.
Why is this correct? D. A custom Apache Beam connector allows reading the proprietary format directly within Dataflow. Streaming the data into BigQuery using Avro format is highly efficient and minimizes resource consumption. Why are the others incorrect? A. Using a cloud function for periodic batch jobs does not fulfill the requirement to stream the data. B. A standard Dataflow pipeline lacks native support for reading the proprietary data format without a custom connector. C. Apache Hive on Dataproc is typically used for batch processing rather than streaming, and CSV is a less efficient format than Avro.
An online brokerage company requires a high-volume trade processing architecture. You need to create a secure queuing system that triggers jobs. The jobs will run in Google Cloud and call the company's Python API to execute trades. You need to efficiently implement a solution. What should you do? The options are: Option A, use a pub/sub push subscription to trigger a cloud function to pass the data to the Python API. Option B, write an application hosted on a compute engine instance that makes a push subscription to the pub/sub topic. Option C, write an application that makes a queue in a NoSQL database. Option D, use Cloud Composer to subscribe to a pub/sub topic and call the Python API.
To arrive at the correct answer, we focus on the keywords: high volume, secure queuing system, triggers jobs, call the company's Python API, efficiently implement.
The correct answer is option A, use a pub/sub push subscription to trigger a cloud function to pass the data to the Python API.
Why is this correct? A. Pub/sub provides a scalable, secure queuing system. Using a push subscription to trigger a cloud function provides an efficient, serverless event-driven architecture that can easily execute jobs and call the Python API without managing infrastructure. Why are the others incorrect? B. Hosting an application on compute engine requires managing underlying infrastructure, which is less efficient to implement and scale than a serverless approach. C. Using a NoSQL database as a queuing system is an anti-pattern requiring significant custom development, failing the requirement to efficiently implement a solution. D. Cloud Composer is an orchestration service for complex workflows and batch processing, not for simple, high-volume real-time event triggering.
Your company wants to be able to retrieve large result sets of medical information from your current system, which has over 10 TBs in the database, and store the data in new tables for further query. The database must have a low-maintenance architecture and be accessible via SQL. You need to implement a cost-effective solution that can support data analytics for large result sets. What should you do? The options are: Option A, use Cloud SQL, but first organize the data into tables. Use joining queries to retrieve data. Option B, use BigQuery as a data warehouse. Set output destinations for caching large queries. Option C, use a MySQL cluster installed on a compute engine managed instance group for scalability. Option D, use Cloud Spanner to replicate the data across regions. Normalize the data in a series of tables.
To arrive at the correct answer, we focus on the keywords: retrieve large result sets, over 10 TBs, store the data in new tables for further query, low maintenance architecture, accessible via SQL, cost-effective solution, data analytics.
The correct answer is option B, use BigQuery as a data warehouse. Set output destinations for caching large queries.
Why is this correct? B. BigQuery is a fully managed, serverless data warehouse perfect for analytics and accessible via SQL. Writing large query results to destination tables directly satisfies the requirement to store large result sets in new tables for further query. Why are the others incorrect? A. Cloud SQL is a relational database designed for transactional workloads, OLTP, not for running data analytics on over 10 TBs of data. C. Installing and managing a MySQL cluster on compute engine requires significant operational overhead, which violates the requirement for a low-maintenance architecture. D. Cloud Spanner is a highly scalable relational database designed for global OLTP workloads. It is not optimized for data analytics and would not be a cost-effective solution.
You have 15 terabytes of data in your on-premises data center that you want to transfer to Google Cloud. Your data changes weekly and is stored in a POSIX-compliant source. The network operations team has granted you 500 megabits per second bandwidth to the public internet. You want to follow Google recommended practices to reliably transfer your data to Google Cloud on a weekly basis. What should you do? The options are: Option A, use Cloud Scheduler to trigger the SUDL command. Use the M parameter for optimal parallelism. Option B, use Transfer Appliance to migrate your data into a Google Kubernetes Engine cluster, and then configure a weekly transfer job. Option C, install Storage Transfer Service for on-premises data in your data center, and then configure a weekly transfer job. Option D, install Storage Transfer Service for on-premises data on a Google Cloud virtual machine, and then configure a weekly transfer job.
To arrive at the correct answer, we focus on the keywords: 15 terabytes of data, on-premises data center, changes weekly, POSIX-compliant source, 500 megabits per second bandwidth, reliably transfer your data to Google Cloud on a weekly basis.
The correct answer is option C, install Storage Transfer Service for on-premises data in your data center, and then configure a weekly transfer job.
Why is this correct? C. Storage Transfer Service for on-premises data is specifically designed to reliably transfer data from POSIX-compliant file systems in an on-premises data center to Google Cloud, supporting scheduled recurring transfers like weekly updates. Why are the others incorrect? A. SUDL is not the Google recommended practice for large-scale enterprise data transfers. It lacks managed reliability, error recovery features, and bandwidth management compared to Storage Transfer Service. B. Transfer Appliance is a hardware solution for offline data migration used when bandwidth is too low for online transfers. It is not suitable for ongoing, weekly data synchronization. D. The Storage Transfer Service agent must be installed on machines located in your on-premises data center to access the local POSIX-compliant source, not on a virtual machine in Google Cloud.
You are designing a system that requires an ACID-compliant database. You must ensure that the system requires minimal human intervention in case of a failure. What should you do? The options are: Option A, configure a Cloud SQL for MySQL instance with point-in-time recovery enabled. Option B, configure a Cloud SQL for PostgreSQL instance with high availability enabled. Option C, configure a Bigtable instance with more than one cluster. Option D, configure a BigQuery table with a multi-region configuration.
To arrive at the correct answer, we focus on the keywords: ACID-compliant database, minimal human intervention in case of a failure.
The correct answer is option B. Configure a Cloud SQL for PostgreSQL instance with high availability enabled.
Why is this correct? B. Cloud SQL for PostgreSQL is an ACID-compliant database. Enabling high availability configures automatic failover, satisfying the requirement for minimal human intervention in case of a failure. Why are the others incorrect? A. While Cloud SQL is ACID-compliant, point-in-time recovery requires manual human intervention to perform the restore process after a failure. C. Cloud Bigtable is a NoSQL wide column store and does not support full ACID compliance for multi-row transactions. D. BigQuery is an analytical data warehouse, not a standard ACID-compliant transactional database designed for transactional workloads.
You are implementing workflow pipeline scheduling using open source-based tools and Google Kubernetes Engine, GKE. You want to use a Google managed service to simplify and automate the task. You also want to accommodate shared VPC networking considerations. What should you do? The options are: Option A, use Dataflow for your workflow pipelines. Use Cloud Run triggers for scheduling. Option B, use Dataflow for your workflow pipelines. Use shell scripts to schedule workflows. Option C, use Cloud Composer in a shared VPC configuration. Place the Cloud Composer resources in the host project. Option D, use Cloud Composer in a shared VPC configuration. Place the Cloud Composer resources in the service project.
To arrive at the correct answer, we focus on the keywords: workflow pipeline scheduling, open source-based tools, Google Kubernetes Engine, GKE, Google Managed Service, shared VPC networking considerations.
The correct answer is option D. Use Cloud Composer in a shared VPC configuration. Place the Cloud Composer resources in the service project.
Why is this correct? D. Cloud Composer is a managed open-source Apache Airflow service built on GKE. In a shared VPC configuration, Cloud Composer resources must reside in the service project while consuming network resources from the host project. Why are the others incorrect? A. Dataflow is a data processing service, not an open-source workflow scheduler. Cloud Run triggers do not satisfy the requirement for an open-source-based scheduling tool. B. Dataflow is not an open-source workflow scheduler. Additionally, using shell scripts for scheduling does not fulfill the requirement of utilizing a Google managed service for automation. C. While Cloud Composer is the correct service, placing its resources in the host project violates shared VPC design, which dictates that compute resources should be placed in the service project.
You are using BigQuery and Data Studio to design a customer-facing dashboard that displays large quantities of aggregated data. You expect a high volume of concurrent users. You need to optimize the dashboard to provide quick visualizations with minimal latency. What should you do? The options are: Option A, use BigQuery BI Engine with materialized views. Option B, use BigQuery BI Engine with logical views. Option C, use BigQuery BI Engine with streaming data. Option D, use BigQuery BI Engine with authorized views.
To arrive at the correct answer, we focus on the keywords: dashboard, large quantities of aggregated data, high volume of concurrent users, quick visualizations with minimal latency.
The correct answer is option A. Use BigQuery BI Engine with materialized views.
Why is this correct? A. BigQuery BI Engine provides sub-second query response times for Data Studio dashboards. Combining it with materialized views, which pre-compute and cache aggregated data, ensures minimal latency and efficiently handles large data volumes in high concurrency. Why are the others incorrect? B. Logical views execute the underlying query each time they are accessed. This does not pre-compute aggregations, leading to higher latency and increased costs under high concurrency compared to materialized views. C. Streaming data focuses on real-time data ingestion. It does not address the performance optimization needed for querying and displaying large quantities of aggregated data in a dashboard. Why are the others incorrect? D. Authorized views are designed for access control, allowing you to share query results without granting access to underlying tables. They do not optimize performance or reduce latency.
Government regulations in the banking industry mandate the protection of clients' personally identifiable information, PII. Your company requires PII to be access controlled, encrypted, and compliant with major data protection standards. In addition to using cloud data loss prevention, Cloud DLP, you want to follow Google recommended practices and use service accounts to control access to PII. What should you do? The options are: Option A, assign the required identity and access management (IAM) roles to every employee, and create a single service account to access project resources. Option B, use one service account to access a Cloud SQL database, and use separate service accounts for each human user. Option C, use cloud storage to comply with major data protection standards. Use one service account shared by all users. Option D, use cloud storage to comply with major data protection standards. Use multiple service accounts attached to IAM groups to grant the appropriate access to each group.
To arrive at the correct answer, we focus on the keywords: compliant with major data protection standards, use service accounts to control access.
The correct answer is option D, use cloud storage to comply with major data protection standards. Use multiple service accounts attached to IAM groups to grant the appropriate access to each group.
Why is this correct? D. Cloud storage is compliant with major data protection standards. Using multiple service accounts attached to IAM groups follows Google's recommended practice for managing access efficiently and securely. Why are the others incorrect? A. Assigning roles to every employee and using a single service account violates the principle of least privilege and obscures accountability. B. Service accounts are meant for applications and workloads, not for individual human users who should authenticate with their own credentials. C. Sharing one service account among all users makes auditing impossible and violates the principle of least privilege.
You need to migrate a Redis database from an on-premises data center to a memory store for Redis instance. You want to follow Google recommended practices and perform the migration for minimal cost, time, and effort. What should you do? The options are: Option A, make an RDB backup of the Redis database, use the SUDL utility to copy the RDB file into a cloud storage bucket, and then import the RDB file into the memory store for Redis instance. Option B, make a secondary instance of the Redis database on a compute engine instance and then perform a live cutover. Option C, create a Dataflow job to read the Redis database from the on-premises data center and write the data to a memory store for Redis instance. Option D, write a shell script to migrate the Redis data and create a new memory store for Redis instance.
To arrive at the correct answer, we focus on the keywords: migrate a Redis database from an on-premises data center to a memory store for Redis instance, Google recommended practices, minimal cost, time and effort.
The correct answer is option A, make an RDB backup of the Redis database, use the SUDL utility to copy the RDB file into a cloud storage bucket, and then import the RDB file into the memory store for Redis instance.
Why is this correct? A. Memory store for Redis natively supports importing data using RDB snapshots stored in cloud storage. This is the Google recommended approach for migration, requiring the least amount of custom development, time, and effort. Why are the others incorrect? B. Setting up a secondary instance on Compute Engine for a live cutover is complex, requires significant manual configuration, and is not a direct migration path to memory store. C. Developing and maintaining a custom Dataflow job requires significant engineering time and effort, violating the requirement for minimal cost, time, and effort. D. Writing a custom shell script involves unnecessary development and testing effort, whereas native RDB import provides a reliable and Google-recommended solution.
Your platform on your on-premises environment generates 100 gigabytes of data daily, composed of millions of structured JSON text files. Your on-premises environment cannot be accessed from the public internet. You want to use Google Cloud products to query and explore the platform data. What should you do? The options are: Option A, use Cloud Scheduler to copy data daily from your on-premises environment to cloud storage. Use the BigQuery data transfer service to import data into BigQuery. Option B, use a transfer appliance to copy data from your on-premises environment to cloud storage. Use the BigQuery data transfer service to import data into BigQuery. Option C, use transfer service for on-premises data to copy data from your on-premises environment to cloud storage. Use the BigQuery data transfer service to import data into BigQuery. Option D, use the BigQuery data transfer service dataset copy to transfer all data into BigQuery.
To arrive at the correct answer, we focus on the keywords: on-premises environment, 100 gigabytes of data daily, cannot be accessed from the public internet.
The correct answer is option C, use transfer service for on-premises data to copy data from your on-premises environment to cloud storage. Use the BigQuery data transfer service to import data into BigQuery.
Why is this correct? C. Transfer service for on-premises data uses local agents to securely transfer data to cloud storage without public internet access. BigQuery data transfer service then automates loading this data into BigQuery for querying. Why are the others incorrect? A. Cloud Scheduler is merely a job scheduler and lacks the native capability to extract data from an isolated on-premises environment. B. Transfer appliance is a physical offline hardware device intended for migrating massive petabyte-scale datasets, making it entirely impractical for daily 100 gigabytes recurring transfers. D. BigQuery data transfer service dataset copy is used to copy existing datasets between BigQuery locations or projects, not to ingest data directly from on-premises environments.
A TensorFlow machine learning model on Compute Engine virtual machines, N2 Standard 32, takes 2 days to complete training. The model has custom TensorFlow operations that must run partially on a CPU. You want to reduce the training time in a cost-effective manner. What should you do? The options are: Option A, change the VM type to N2 32. Option B, change the VM type to E2 Standard 32. Option C, train the model using a VM with a GPU hardware accelerator. Option D, train the model using a VM with a TPU hardware accelerator.
To arrive at the correct answer, we focus on the keywords: takes 2 days to complete training, custom TensorFlow operations that must run partially on a CPU, reduce the training time in a cost-effective manner.
The correct answer is option C, train the model using a VM with a GPU hardware accelerator.
Why is this correct? C. GPUs significantly accelerate TensorFlow model training while fully supporting custom operations that must fall back and run partially on the CPU, making this the most effective way to reduce training time. Why are the others incorrect? A. Switching to a high-memory machine type provides more RAM but does not increase computational power, which is the primary bottleneck for machine learning training. B. The E2 Standard 32 machine type offers similar or slightly less CPU performance compared to the current N2 Standard 32, so it will not decrease the training time. D. TPUs are highly specialized and do not support custom TensorFlow operations that must execute partially on a CPU. Using a TPU would cause the training job to fail.
You want to create a machine learning model using BigQuery ML and create an endpoint for hosting the model using Vertex AI. This will enable the processing of continuous streaming data in near real time from multiple vendors. The data may contain invalid values. What should you do? The options are: Option A, create a new BigQuery dataset and use streaming inserts to land the data from multiple vendors. Configure your BigQuery ML model to use the ingestion dataset as the framing data. Option B, use BigQuery streaming inserts to land the data from multiple vendors where your BigQuery dataset ML model is deployed. Option C, create a pub/subtopic and send all vendor data to it. Connect a cloud function to the topic to process the data and store it in BigQuery. Option D, create a pub/subtopic and send all vendor data to it. Use Dataflow to process and sanitize the pub/sub data and stream it to BigQuery.
To arrive at the correct answer, we focus on the keywords: continuous streaming data, near real-time, multiple vendors, data may contain invalid values.
Correct answer is option D, create a pub/subtopic and send all vendor data to it. Use Dataflow to process and sanitize the pub/sub data and stream it to BigQuery.
Why is this correct? D. Pub/sub reliably ingests near real-time continuous streaming data from multiple vendors, while Dataflow provides the necessary stream processing to sanitize invalid values before writing to BigQuery. Why are the others incorrect? A. Direct streaming inserts into BigQuery lack the data processing capabilities required to sanitize or filter the invalid values before ingestion. B. Directly streaming data into BigQuery does not address the need to process and clean the invalid values present in the data stream. C. While Cloud Functions can process events, Dataflow is the recommended and more robust service for continuous, high-volume stream processing and sanitization.
You have a data processing application that runs on Google Kubernetes Engine, GKE. Containers need to be launched with their latest available configurations from a container registry. Your GKE nodes need to have GPUs, local SSDs, and 8 gigabits per second bandwidth. You want to efficiently provision the data processing infrastructure and manage the deployment process. What should you do? The options are: Option A, use Compute Engine startup scripts to pull container images, and use cloud commands to provision the infrastructure. Option B, use Cloud Build to schedule a job using Terraform Build to provision the infrastructure and launch with the most current container images. Option C, use GKE to autoscale containers, and use cloud commands to provision the infrastructure. Option D, use Dataflow to provision the data pipeline, and use Cloud Scheduler to run the job.
To arrive at the correct answer, we focus on the keywords: Google Kubernetes Engine, GKE, launched with their latest available configurations, efficiently provision the data processing infrastructure, manage the deployment process.
The correct answer is option B, use Cloud Build to schedule a job using Terraform Build to provision the infrastructure and launch with the most current container images.
Why is this correct? B. Cloud Build automates deployment, and Terraform efficiently provisions infrastructure as code, meeting the requirements to manage deployment and provision specific GKE nodes. Why are the others incorrect? A. Compute Engine startup scripts are not the standard or efficient way to manage GKE container deployments or provision complex GKE infrastructure. C. Autoscaling containers doesn't address the requirement to provision the underlying infrastructure, nodes with GPUs, SSDs, efficiently as code. D. The application already runs on GKE, so switching to Dataflow is incorrect and does not address the GKE cluster provisioning requirements.
You need ads data to serve AI models and historical data for analytics. Long-tail and outlier data points need to be identified. You want to cleanse the data in near real time before running it through AI models. What should you do? The options are: Option A, use cloud storage as a data warehouse, shell scripts for processing, and BigQuery to create views for desired datasets. Option B, use Dataflow to identify long-tail and outlier data points programmatically, with BigQuery as a sink. Option C, use BigQuery to ingest, prepare, and then analyze the data, and then run queries to create views. Option D, use Cloud Composer to identify long-tail and outlier data points, and then output a usable dataset to BigQuery.
To arrive at the correct answer, we focus on the keywords. Long tail and outlier data points need to be identified. Cleanse the data in near real time.
Correct answer is option B. Use Dataflow to identify long tail and outlier data points programmatically, with BigQuery as a sink.
Why is this correct? B. Dataflow is a fully managed streaming analytics service that can cleanse data in near real time and programmatically identify outliers before storing the results in BigQuery. Why are the others incorrect? A. Shell scripts on cloud storage are not suitable for near real-time processing or complex stream data cleansing. C. BigQuery is an analytics data warehouse and does not natively support near real-time stream data cleansing prior to ingestion. D. A cloud composer is an orchestration tool used to schedule workflows, not a data processing engine for near real-time cleansing.
Refer to the attached Picture 1, reference exhibit. You are collecting IoT sensor data from millions of devices across the world and storing the data in BigQuery. Your access pattern is based on recent data, filtered by location_ID and device_version with the following query. You want to optimize your queries for cost and performance. How should you structure your data? The options are: Option A, partition table data by create_date, location_ID, and device_version. Option B, partition table data by create_date, cluster table data by location_ID, and device_version. Option C, cluster table data by create_date, location_ID, and device_version. Option D, cluster table data by create_date, partition by location_ID, and device_version.
To arrive at the correct answer, we focus on the keywords, recent data, filtered by location_ID and device_version. Optimize your queries for cost and performance.
Correct answer is option B. Partition table data by create_date, cluster table data by location_ID, and device_version.
Why is this correct? B. Partitioning by date efficiently limits the data scanned for recent data, directly reducing query costs. Clustering by location_ID and device_version sorts data within those partitions, highly optimizing performance for the specific where clause filters. Why are the others incorrect? A. BigQuery restricts table partitioning to a single column. It is not possible to partition a table by 3 different columns simultaneously. C. Relying solely on clustering misses the strict cost reduction guarantees of date-based partitioning, which explicitly prunes irrelevant data segments before query execution. D. BigQuery only supports partitioning by date, timestamp, datetime, or integer range columns. It does not support partitioning by standard string columns like location_ID or device_version.